Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic at hand this evening is going to be EVAP system diagnosis. And they can be tricky, I guess, in ways, depending on where the problem might lie. And we also have to consider, is it a leak? Because it's not always a leak when we get an EVAP code. Or is it an electrical problem? Or could it be both? Could it be like one of my solenoids is not closing all the way or something like that? So let's just walk through the different components, and then we're going to do kind of a study on a fairly recent vehicle, and then we will go from there. So first off, let's talk about the different components of the EVAP system, the main components anyways. We have the purge solenoid, the vent valve, the canister, the fuel tank pressure sensor, and then there are also maybe some other pumps and associated modules for leak testing. And as we'll see on the vehicle we're going to look at here in a little bit, you might see some check valves and some T's and things of that nature, depending on how the vehicle is set up, how the intake is set up. And naturally aspirated versus turbo mainly is going to be your difference there. But like I said, we'll get to that in a couple minutes. First, let's cover and recap, I guess to say, how does an EVAP system work? What does it do on the vehicle? So we are going to have a few of those main components like we talked about, right? So we're going to have the purge valve, which is going to be the front door, we'll say, it's the one closest to the engine. And then we have the back door, which is going to be our vent valve. So that'd be out by the canister generally. Then we have the canister itself. It's full of charcoal, and that's going to store the vapors from the fuel. So the fuel, as you probably know, gasoline, gases. The vapors are what's the flammable part mainly. So the vapors need to be collected so they don't get out in the atmosphere and contaminate things. So that's what the EVAP system is for. So if we put some default state, is going to be the back door is going to be open because we need to be able to displace the air that's inside the fuel tank in order to put fuel in there. And then the front door is going to be closed by default, so we don't have it affecting, or the engine affecting it when we don't want it to. So first off, we will fill it with fuel. As we're filling with fuel, the vapors are being generated, and they're going to go and they're going to get collected in the canister. So you can see how they kind of flow in there, and they displace the clean air that's in there to the outside. Once it's full, and once the engine gets up to operating temperature, the computer is going to open the purge valve, and that is going to allow the vacuum from the engine to pull on the vapors. They're going to be displaced by outside air. It's going to displace those vapors. They're going to go into the engine, and they're going to be burned. Once that process is done, however long the computer decides it needs to, it is then going to close that back door, the vent valve, and then it is going to draw a vacuum down on the system. So at this point, it'll be closed to the outside, but it'll still be open to the vacuum there. And it's going to generate a vacuum on the system. Once it's done, once it has a vacuum, it's then going to close the front door, and now I have a fully closed system holding it a vacuum. Then the computer is going to wait set amount of time, however long it is, and see whether or not that vacuum decays. In this case, we got time going on. The vacuum's not decaying, so that indicates to me no leak. However, If it does decay over that period of time, depends on how fast it decays. If it decays rapidly, then I have a very large leak. If it decays slowly, then I might have a small leak. And the computer can tell nowadays, even if the gas cap's off, and it can tell where the leak might be coming from. Also, many manufacturers now have resorted to not using engine vacuum to draw down and leak test the system. They're going to leak test it with a vacuum pump that may be 5, 7, or 9 hours later after the vehicle shut off, and any variation in between. So there's a lot of different ways that they can detect leaks nowadays in manufacturers. This is just how it originally was, but I guess to make it more, what's the word I'm looking for? Make it more consistent. There we go. Make it more consistent, they'll use pumps and natural vacuum leak detection and things of that nature. So depending on the size of the leak will depend on what kind of code I get and depend on how I diagnose it. So let's look at a newer EVAP system. This is on a 2022-2023 Grand Wagoneer. And it's got some different things. It's got some additional things. And it might be a little bit different than what you're used to, depending on what you work on. So we have our fuel tank, of course. We have our fuel tank pressure sensor, which actually on this vehicle, it's a little further up. We have the charcoal canister. And then Chrysler has what they call an eSIM. So it's an EVAP system integrity module that it uses to test for leaks. And then, of course, the fuel vapor is going to go through the lines down to the purge solenoid. Now, this is a turbocharged vehicle. This is the turbo 3-liter. So there are check valves in here as well. And there's a T. So we have 1, 2, 3 check valves and what they call an ejector T. So depending on whether or not the engine is running in vacuum or boost. So if it's running in vacuum, it just operates the way we just showed, where it pulls it through the purge solenoid, pulls it out of the charcoal canister. However, if it's in boost, where the intake manifold port is, well, that's going to be under boost too. So it's just going to be pushing that EVAP emissions back. So in that case, it's going to open a check valve and it's going to come down here and it's, oops, click too far. It's going to come down here and then it's going to go into the air box and then go into the intake that way. So either way it gets introduced into the system, it's either whether or not it's before or after the turbo. That's the big thing there. And then due to the way the system's set up, it also has, it's called an OBD vent valve. So that allows to vent vacuum out of here. Also note that on many newer vehicles, they don't just open to the outside air anymore like they used to. Now it's they have filters on there as well, so let any excess vapors be collected in that filter. Right? So here's a look at that purge solenoid. We got a little check valve in the back, like I said, and depending on the status of boost, it's either going to go straight through or it's going to go out that vacuum port out to that ejector T. Here's a different visual on how that would look. So we got the canister there, and then the purge vapors are going to go through here. If we're in vacuum, this check valve will be open, and it will allow it to just come into the intake manifold as it normally would under naturally aspirated circumstances. Once we have boost, we're going to see boost coming through, and it's going to affect this ejector T, and it's going to direct it down to the air box. Also, since it'd be under boost, this check valve would then be closed. Because it'd be pushing back on that check valve, right? And then the OBD vent valve's over here for vent. So here's what that check valve looks like, or the, what do we call it? The ejector T. So boost air is going to come in, it's going to push down on this, it's going to allow purge air through, out to the air box. And the eSIM is the evaporative system integrity module, like we said. So it's got 2 weights inside of it. And depending on how these weights move and how they're affected, because they have little gaskets on them as well. So we have a large weight for pressure testing and a small weight for vacuum testing in there. And we got a little diaphragm there as well. I'm going to walk through a little bit more how that works a little bit later. And then the canister is a little unique, like I said, on this one. That looks unlike many, looks unlike most canisters I've seen. It's actually semi-cylindrical. But there's that eSIM module we just looked at, and then there's that filter we were talking about too, where it doesn't directly go out to outside air. It's a filter to try and capture more of that vapor. And then on this vehicle, the fuel tank pressure sensor is actually like right next to the filler neck, about halfway up in the wheel well. So it's not down on top of the tank. Like many vehicles, it is up a little higher. And I guess their reasoning for that, according to service information, is in case it's in water, you can still vent and you can still have the pressure outside of the water. So I don't know how many rivers I'm fording with my $100,000 Grand Wagon here. But hey, maybe some people will. So they want to keep it out of any water, large bodies of water, I guess. And then here's that vent blocker valve they mentioned as well. So this basically blocks off the system into two halves. So we have the side, the tank will be its own side, and then the canister side will be its own side, just depending on, makes it a little easier to diagnose, I guess, because I can diagnose just the tank side or just the canister side instead of having to diagnose through the whole thing. So that is what there is. That is what that is there for. Now that brings me to codes, right? Remember how I mentioned earlier, we want to see whether or not, is it a leak or is it an electrical problem? Because this could trip some people up. If you don't read the entire code, you just see the word EVAP, oh, it must be a leak. Well, that's not always the case. For example, 440s is just general EVAP problem or a gross leak. 442 is a small leak. 456 is a very small leak. And even a 457 for a gas cap, we've seen that for many, many years. However, if I come over here to a 443, that's a purge control problem. So the purge control solenoid. 446, vent control problem. 452, pressure sensor. 458, purge solenoid. So I would need to see what the definition of the code is. That might also be like the purge, could be purge control high, purge control low, that's electrical. Could be purge flow, might be a little bit of both. It might be an electrical problem and or a leak at the same time, because if it's flowing too much, it's not sealing properly, then that could be the electrical, could be electrically an issue or a mechanical issue inside that solenoid that's causing it not to seal. So you may need to do electrical testing, you may need to do leak testing, you may need to do a little bit of both depending on what the situation is. But if I'm getting one of these and it's nothing obvious, just at a first glance, I'm probably gonna leak test it first. And then if it's any of these over here in electrical code, then I'm probably gonna start by checking the actual unit itself, the purge control solenoid or the vent solenoid or whatever. Check that first and check the circuitry there first. And then if we think we might still have a leak after the fact, then we'll check for leaks. But leak testing. I will tell you, in the dealership that I worked at, this is about 15 years ago, but in the dealership that I worked at, they did not have a EVAP tester, smoke machine, anything like that. And I will tell you, I live in Northeast United States, and we get a lot of rusts. And Subaru like to make their lines out of metal, at least a lot of them. There's a fair amount of rubber too, but the metal lines would go through the metal frame on the vehicle or be on top of the fuel tank, the metal fuel tank. So imagine how much rust was there. And don't even get me started on the filler necks. Oh my goodness. So many problems with filler necks rotting out on the bottom because they put a big plastic cover over it that would collect all the mud and dirt underneath, and then it would just rot. Anyway, I do remember we had this one very, very particularly troublesome one that kept coming back and kept coming back. Finally, we said, you know what? We're just going to go next door to the Chrysler dealership next door, and we're going to take their machine. We're going to borrow it for the day. So they had a nice smoke machine over there, and we put it in, and sure enough, 5 minutes later, oh, look, there's the leak right there. It was actually in the frame where those metal lines would go through. So all the rubber lines had been replaced, all sorts of other things had been replaced, and they just could not find a leak, could not find a leak. So let's put some smoke in it, and magically, where the smoke comes out, guess where the leak is? Right? That's the easiest way to test that sort of thing. So if you are doing the EVAP work without a smoke machine or something like that, I feel for you because I was there, but I would definitely, in my mind, I would want to rectify that sooner than later. One example is this is the brand new EELD 700A that just came out, so that replaces the EELD 500. So it has a low pressure smoke machine. It's got some interesting little features on it. I can do air only, so you don't have to run smoke through it. So it's a very well lit gauge, I guess, in the back, flow gauge down there. It's good down to 10,000. So when I do hook up the smoke machine, though, I'm going to want to use the, if there's a port under the hood, which many vehicles have, but I suppose there's probably an equal number of vehicles that don't. But if you do have a service port, pop the cap off. You want to make sure you pull the Schrader valve out too, and it is a lefty-tighty, righty-loosey situation, so it is a reverse thread, so make sure you turn it clockwise to remove it. And then you would connect the tool, the adapter to it, and allow smoke into the system. Now, depending on what side of the system you needed to test, maybe you crack a line in a different place. I've seen plenty of adapters out there where it's for all those quick connects that all the manufacturers use now, so you can just pop the quick connect off, pop the adapter in there, and it'll hook right up to the smoke machine. And first thing we need to check is make sure that the vent valve can close, because we need to close the system in order to put smoke in it to put enough pressure in there to allow a leak out. In this case, this is a leaking vent valve, so that needs to get addressed before we do anything else. That could very well be the leak, but that definitely needs to be addressed, because then we can't seal the system and allow the smoke to fill the system if we'd have that. Another example, on top of a fuel tank, this is a cross-threaded fuel sending unit. So they couldn't really tell that it was cross-threaded, and just the gasket wasn't sealing well enough, and out comes the smoke, right? Normally not that easy to see on top of a fuel tank. And then another example here, this is actually hoses on the EVAP canister. So you can see we got multitude of hoses there. That hose is not looking, it looks like it's seen better days anyways, but you can definitely see that smoke coming out. And if you were looking at it from maybe this side, you wouldn't have been able to see that. Might want to condemn the hose anyways, because it's looking pretty dry rotted, but smoke it quick. Have the car up in the air, take a quick look underneath with a flashlight. Where's the smoke? There you go. Easy peasy. All right, and then electrical testing. If we're going to test, we'd probably use like a meter or something like that. If you have a snap-on scan tool with a scope and meter function, you will have guided component tests as well, and it's going to tell you how that piece works and what the pinouts look like and the best place to test it. And when you go in and actually do the test, it's going to set the test up for you. It's all specific to the vehicle, to the component on the vehicle. I'm going to show you a couple of those here in a minute. But if you have this, it is very underutilized out in the market, I know. And there's over 8 million tests in here, not just EVAP tests, obviously, but pretty much anything you would need to test on the EVAP system electrically would be in there as well. So let's go live and talk about a few of those things. First one I want to do is the Grand Wagoneer. And on this one, we do have the guided component test, right? So that's that new 3-liter turbo engine. And we have EVAP. And you see we got the eSIM unit. So the eSIM, or Evaporative System Integrity Monitor, is very similar to the NVLD, which is what they used to use, which is natural vacuum leak detection, although it does not require a solenoid. The eSIM mounts directly to the canister. The assembly consists of a housing, a small weight, and a large weight that service check valves, a diaphragm, a switch, and a cover. There's a check valve for each of the weights in the eSIM assembly, with a seal attached at the end of each weighted check valve. The large weight check valve seals for pressure, the small weight check valve seals for vacuum. After the vehicle is shut down, the fuel system is sealed. As it cools, the internal pressure will drop. If the pressure drops enough to close the switch, the small leak test is passed. If the small leak test does not run, the PCM will run a medium and large leak test on startup. Using the engine vacuum, the fuel system will be drawn into a vacuum to test its integrity. Right, so it's going to use the natural vacuum, similar to NVLD. So as the fuel cools and as the vapors condense, it's going to create a vacuum inside a theoretically sealed system. If it's sealed enough, then you will get a vacuum to lift that small thing off, and it flips the switch. Fuel tank isolation valve, that's what we were talking about earlier, where it could split it into two sections. Normally closed fuel tank isolation valve located between the fuel tank and charcoal canisters used to manage pressure and vacuum in the fuel tank. When it's closed, it splits the EVAP system into two separate diagnosable sections during leak testing, the fresh air side and the fuel tank side. There's a power and ground for that. Fuel tank pressure sensor. It's going to be like much like many other fuel tank pressure sensors. There's a 3-wire 5-volt unit that varies its output based on the pressure of the fuel vapor. And then we have the OBD vent valve, which is in series with the purge valve. The OBD valve needs to be turned on to allow vapors to get to the purge valve and open the eSIM switch for diagnostics. Power is from the ASD relay and ground is controlled by the PCM. So power and ground again. And then we have the purge solenoid itself. Purge it's normally closed solenoid. Use the purge fuel vapors in the EVAP canister. Once again, a 2-wire solenoid on that one as well. And then if we want to go into service information, I will say there's two reasons I picked this vehicle. Reason number one was because it had a lot of interesting other components that you don't normally see. And the other reason I did was because it had such a really nice diagram, as we saw earlier. So if I go into component operation, it's going to tell me all about it. And there's that really nice looking wiring or nice diagram. It's amazing how few manufacturers put out good diagrams. Like oftentimes it's just a bunch of boxes and stuff, which granted some of the ones in this article are too, but it's nice to have colors and kind of denote where everything is. As a tech, I like that. So I can see what everything's supposed to look like. Most of the time it looks like this, which is actually still better than some manufacturers do. And then there's the other stuff we have. There's the eSIM. It's going to tell you how all this stuff works. Internal tank valves. There's tank vent valves, grade vent valves, and fuel filler check valves in there as well. OBD vent valve. Purge solenoid. Vent blocker valve, they call it. Now, one thing I wanted to look at the... wrong, went too far. Charcoal canister fresh air filter is mounted at a high point on the vehicle next to the filler, so in the event the vehicle is used in deeper water, the tank can still vent through the charcoal canister. The hose connects the fresh air filter to the EVAP system integrity module. Fresh air filter prevents dirt and contamination from entering the system during purging. There you go. And the fuel tank pressure sensor doesn't explain why it is either, but same reasoning. So we can still do stuff even if we're in deep water. Because that seems like something that would happen a lot. All right, so that's the Jeep. Let's go to this Cadillac. There's a new test added on this Cadillac. So if I go into functional tests, we still have the EVAP service bay test, which is on pretty much any GM vehicle. That forces you to forces the monitor while in the bay. You still have to drive the vehicle too, but forces the monitor. But this just got added as the EVAP emissions canister purge valve leak test. So it is not a not necessarily like a bidirectional control, right? It is a bidirectional control, but it sets it. You can set it to closed or open, and then release control of the module as well, and it holds it for 30 seconds for leak testing instead of just turning it on and off. So if I wanted to do that, it'll wait for 30 seconds, and it'll hold it. And that's just a nice, easy test for you to do with that. And let's see. Next, I want to go to the Focus, 2018 Ford Focus. This Ford does some things a little differently as well. Just like to give you a good sample cross-section of what manufacturers are doing here. So we have a gross leak test, a small leak test, and then a cold EVAP system cold soak time bypass. So this has a wait time before it runs the monitor. And if you want to run the monitor like, hey, I just did some work on this car, I don't want to wait hours, then you would do this. So it also erases freeze frame data, resets the OBD monitors, and clears engine and transmission code. Bypass EVAP. So cold soak time, key must be on with the engine running. And then it's going to start the test. Do not cycle the ignition key off because it needs to run through that ignition cycle. Cold soak time bypass. Ready to perform EVAP readiness monitor. And then you would go through and do the drive cycle for the monitor. And then you would see right here whether or not it was passed or not. Or complete. And then this should have some guided component tests as well. EVAP. Just gives you just kind of a general overview of EVAP and how it works. And then we have fuel tank pressure sensor, purge solenoid, vent solenoid. So we got all those different things. Got the connector views, wire colors. I want to do a voltage test. It'll just tell me what voltage I need to see. And so on. All right, and last I want to go into a Ram truck real quick. This also has something different in there as well. So miscellaneous functions, it has a PCM small leak verification test. So that's going to verify to detect a leak. Perform any service bulletins or flash updates related to evaporative fault codes before proceeding. This procedure uses pressure over time to detect a leak. There are 5 possible test phases. To get a pass on test phase 2, the evaporative system will need to be either heating up or cooling down. So these are things with these tests. When you're talking about scripted tests or things like this, you need to make sure there are going to be parameters that need to be met. Sometimes the manufacturer tells you what they are. Sometimes they don't tell you what they are. In this case, they tell you. So to pass test phase 2, you'll either need to be heating up or cooling down the system. So don't be at like full operating temperature to do this, unless I guess you could be cooling down at that point, but it might take a little while. And then it's going to give me an error. If there's a possible leak or the system is very stable, the second intrusive part of the test as phase 4 and 5 will run. And it'll be an automated test, and I can't go any further than that because the engine's technically running. And then for that one, we also have guided component test for that. So EVAP system's got the eSIM unit, just like the Wagoneer, fuel tank pressure sensor, and the purge solenoid for that one. All right, so that is EVAP in a nutshell. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.